Hello everyone, I am Faranjum from Sri Venkateshwara College of Engineering, Bangalore. The topic for today's presentation is Software and Software Engineering from this course, Software Engineering and Project Management. First, we will see what is software. Software is a set of programs that allows the users to perform a well-defined function or specified task. Software is responsible for directing all computer-related devices and instructing them regarding what and how the task is to be performed. Software also includes the data that these programs use and manipulate, such as text documents, images, and databases. The written materials such as requirements, design specifications, and user guides that accompany software are also considered part of the software. Nature of software. Software is developed or engineered. It is not manufactured in the classic sense. Although some similarities exist between software development and hardware manufacturing, the two activities are fundamentally different. In both activities, high quality is achieved through design, but the manufacturing phase for hardware can introduce quality problems that are non-existent. For software, software projects cannot be managed as if they were manufacturing projects. Software doesn't wear out. Software is not susceptible to the environmental maladies that cause hardware to wear out. In theory, therefore, the failure rate curve for software should take the form of the idealized curve, as shown in this figure. Undiscovered defects will cause high failure rates early in the life of a program. However, these are corrected and the curve flattens as shown. The idealized curve is an oversimplification of actual failure models for software. However, the implication is clear. Software doesn't wear out, but it does deteriorate. Although the industry is moving towards component-based construction, most software continues to be custom-built. As an engineering discipline evolves, a collection of standard design components is created. The reusable components have been created so that the engineer can concentrate on the truly innovative elements of a design, that is, the parts of the design that represent something new. A software component should be designed and implemented so that it can be reused in many different programs. Modern reusable components encapsulate both data and the processing that is applied to the data, enabling the software engineer to create new applications from reusable parts. Software process. A process defines who is doing what, when, and how to reach a certain goal. A process is a collection of activities, actions, and tasks that are performed when some work product is to be created. An activity strives to achieve a broad objective and is applied regardless of the application domain, size of the object, complexity of the effort, or degree of rigor with which software engineering is to be applied. An action encompasses a set of tasks that produce a major work product. A task focuses on a small, well-defined objective. Example, conducting a unit test that produces a tangible outcome. A generic process framework for software engineering encompasses 5 activities: communication, planning, modeling, construction, and deployment. Communication. Before any technical work can commence, it is critically important to communicate and collaborate with the customer. Planning. The planning activity creates a map called a software project plan, defines the software engineering work by describing the technical tasks to be conducted, the risks that are likely, the resources that will be required, the work products to be produced, and a work schedule. Modeling. You create a sketch of the thing so that you will understand the big picture. A software engineer does the same thing to creating models to better understand software requirements and the design that will achieve those requirements. Construction. This activity combines code generation and the testing that is required to uncover errors in the code. Deployment. The software is delivered to the customer who evaluates the delivered product and provides feedback based on the evaluation. Software engineering. Software engineering is an engineering branch related to the evolution of software product using well-defined scientific principles, techniques, and procedures. The result of software engineering is an effective and reliable software product. Software engineering is required due to the following reasons: to manage large software for more scalability, cost management, to manage the dynamic nature of software, and for better quality management. Software myths. Today, most knowledgeable software myths. Today, most knowledgeable software engineering professionals recognize myths for what they are: misleading attitudes that have caused serious problems for managers and practitioners alike. However, old attitudes and habits are difficult to modify, and remnants of software myths remain. Management myths. Managers with software responsibility, like managers in most disciplines, are often under pressure to maintain budgets, keep schedules from slipping, and improve quality. Myth is that we already have a book that's full of standards and procedures for building software. Won't that provide my people with everything they need to know? Reality is that the book of standards may very well exist, but is it used? Are software practitioners aware of its existence? Does it reflect modern software engineering practice? Is it complete? Is it adaptable? Is it streamlined to improve time to delivery while still maintaining a focus on quality? In many cases, the answer to all these questions is no. Customer myths. A customer who requests computer software may be a person at the next desk, a technical group down the hall, the marketing or sales department, or an outside company that has a requested software under contract. The myth is that a general statement of objectives is sufficient to begin writing programs. We can fill in the details later. Reality is that although a comprehensive and stable statement of requirements is not always possible, an ambiguous statement of objectives is a recipe for disaster. Unambiguous requirements are developed only through effective and continuous communication between customer and developer. Practitioner myths. Myths that are still believed by a software practitioner have been fostered by over 50 years of programming culture. During the early days, programming was viewed as an art form. Old ways and attitude die hard. The myth is that once we write the program and get it to work, our job is done. And the reality is that someone once said that the sooner you begin writing code, the longer it will take you to get done. Industry data indicate that between 60 and 80% of all effort expended on software will be expended after it is delivered to the customer for the first time. Thank you for watching the video.